Right, so welcome to the second lecture. Right, कम रह गए आप लोग, क्या हुआ? ड्रॉप आउट हो गए बात इतनी जल्दी? अभी तो एक ही लेक्चर हुआ अभी. अच्छा चलें. So what did we discuss last time? क्या बात हुई थी? याद है? काफ़ी कुछ डिस्कस हुआ.
Definitions, vocabulary.
कुछ vocabulary, right? कुछ याद है क्या डिस्कस हुई थी vocabulary?
Signals क्या होते हैं, system क्या होते हैं,
That's
analog
the
क्या होते
title
हैं.
itself, right? So what was the signal?
Set of instructions, information.
Some set of information or data, yeah. The system क्या था? Processing, right? And the processing can also include generating or receiving that information or data, yeah. Okay. After that, we started looking into, say, some categories or some further terms like what is a continuous time signal or system, what is discrete time, right? वो हमने डिस्कस किया था. फिर हम कहाँ गए थे? If I recall correctly, we were at impulse. We discussed, right? So I gave you from English to a general conceptual understanding, then we went on to actual mathematical description, right? So the unique thing about the delta function, इसको हम delta function भी कहते हैं, right? हम बनाते हैं the impulse. The unique thing about it is that it is defined by its properties. Okay, so if any function that satisfies these two properties is a delta function. Doesn't matter the finely stupid shape क्या था. Okay, we're only interested in these properties. And I think I stopped here. This was for the continuous time case. Yes, we have already discussed continuous time versus discrete time. Yeah. So ये definitions, they work when t is continuous. Okay. Whereas a lot of what we do in signals and systems in modern times is discrete, or further it is digital. So we also need to redo these in discrete time. Now in discrete time, the delta function is much simpler. कोई इसमें advanced चीज़ें नहीं है. It's very simple. What is this formula saying? You know how to read a piecewise formula? Yes. So it's a piecewise definition. It says that delta n equals 1 when n is 0. Yes, and it is 0 when n is not 0. So it is almost similar to this thing where it was saying the area should be 1 and it should only be non-zero at t equal to 0. In discrete time it is much simpler. We don't need the area, we just assign it a value of 1, yes, at t or n equals 0.
Sir, I'm confused. इसका area 1 कैसे हो सकता है? क्योंकि जो ये piecewise जो define कर रहा है वो ये कह रहा है कि ये 0 के अलावा कहीं पे भी जो है exist नहीं करता. तो इसका अगर कोई वो नहीं, कोई width नहीं है इसकी, जितने मर्जी partitions बना दे नहीं है, तो फिर इसका area 1 कैसे हो सकता है?
देखिए, in this case, discrete case में तो we're not saying area has to be 1, right? This is just one value. Okay. In discrete case, area doesn't have any meaning for us. Yeah. In the continuous case, if you're talking about that, then mathematically we often show that it could have, let's say, a shape like this, where epsilon is approaching 0. Okay. So the product of these two, as epsilon becomes infinitesimally small, is 1 over epsilon times epsilon. Right? So दोनों values same rate पे decrease करें, ऐसे?
सर आप negative epsilon upon 2, that implies कि इस ये मतलब let's say minus 0.01 या से लेकर 0.01 तक exist करता है.
But epsilon is approaching 0. That is the idea of limits, no? Right? So limiting case where epsilon approaches 0, this becomes thinner and thinner, right, and taller, but during the whole process the area under this rectangle remains 1, right? क्योंकि ये area क्या है इसका? Okay, minus epsilon by 2 to epsilon by 2. What's the width? Epsilon. What's the height? 1 over epsilon. अभी अगर epsilon को अभी देखें just what's the area? 1. Yeah, make epsilon a bit smaller. What's the area? Then make it a bit smaller still. What's the area? Right? So it's a mathematical construct. जैसे limits का if when you first study calculus, right? आप जब वो area को as a form of limiting पढ़ते हैं ना, infinitesimally small करते हैं, वहाँ पे फिर एक jump है बस conceptual या mathematical, right? So it is like that. But again, I've been saying this from our perspective in continuous time. These properties are what we are looking for. Okay, these are the properties that we want. The actual shape won't matter that much, and these properties or this kind of a definition will come in handy later. जब हम continuous time processes को signals को we will try to sample them, we will find that this kind of definition helps us a lot. Okay, so again, let's keep this in mind. Right now the area is 1. Yes, if you reduce epsilon, yeah, क्योंकि by writing it like that you're talking about epsilon over epsilon, right? So if you keep reducing epsilon, दोनों को छोटे भी हो जाएं तब भी दोनों एक दूसरे को कैंसिल कर देगा, तो 1 1 ही आता जाएगा हर दफा, right? So in the limiting case, remember area is a limiting case of the sum. Continuous sum होता है ना, integral क्या होता है, पढ़ा है ना? So as soon as you go into integral, you're already talking about infinitesimally small areas, right? Otherwise तो आप sum लिख देते हैं ना उसका. So integral is a continuous sum, yeah, and the continuous sum thing requires infinitesimally small intervals or regions, yeah. So थोड़ा सा और इस पे आप करें, बिल्कुल I agree. इस तरह की चीज़ें थोड़ी सी they are more the limits itself मैं अलग बहुत से not an easy concept or to start with or to say accept right away ना. आप पता है limits वगैरह में the area of a point is क्या होता है, 0 होता है, हो सकता है नहीं होता ना. So area of a point is 0, but the whole table or the whole frame is made up of lots of points, right? So सारे 0 areas मिलके कैसे एक plane बना सकते हैं, line बना सकते हैं, नहीं बना सकते. But we say the area of a point is 0. Yes. So इसी तरह ये एक वो है conceptual construct है ये. Right. So the discrete case, as I said, is very simple. You say it has a value 1. At delta n, n equals 0, and it is 0 otherwise. So the second case is which you will see a lot. So the first one was impulse, yeah, suddenly appears and gone. The other one is sometimes we want to give a sustained push to a system to see its reaction, and there you will see it's used a lot, the step function. And the step function goes like this. Before time 0, okay, t0 means some reference time, doesn't have to be 0. Later we'll adjust this. But for now, before time 0, there was no input to the system. Okay, then you gave it an input and sustained it. एक fixed input आपने उसको दिया. It's like turning on a switch. ये light है, there is no input, it's off, you turn on the switch. So before t equal to 0, it was no power going into the light, yeah. Turn on the switch, power goes. Now we know from your circuit analysis also that ये infinitely एकदम तो नहीं होती है, थोड़ा सा एक curve होता है जिसको हम ignore करते हैं, जो की speed होती है. So again this jump, this continuity here is again a mathematical construct or conceptual construct. It doesn't affect really real systems में there will always be a slight curve उसके साथ 0 से 1. आप जब ये ऑन भी करते हैं तो infinite speed से नहीं लाइट पावर चली जाती है आपकी बल्ब को, right? There is a curve. वो हम for the sake of simplicity, for the sake of really writing things more elegantly in mathematics, we have these kind of conceptual functions, or they come in handy in analysis. And when after general analysis, when we really, if somebody really wants to ask, okay, what happens when you turn on the switch exactly at that moment, or within, let's say, nanoseconds of that, then you go into this line and see, okay, how did the current flow find it. Okay, वो इतनी ज़्यादा precision, let's say this, if I start this course with that, you will all run away, right? So it's usually good to divide and conquer, yeah? So make things simplified, work with those, develop the tools, and when you need, where you need, refine the tool or use more refined methods, yeah? So we have this in continuous time. So how would it look in discrete time? Any idea? This is, well, it is continuous time, yeah? Naveed, this formulation. How would it look in discrete time? Plot draw कर सकते हैं?
पॉइंट्स होंगे,
Points होंगे, किस तरह के होंगे?
ये लाइन, इसी लाइन को ले लो तो पॉइंट बना दो, लाइन ना बनाओ बस.
So
बस पर सीधी लाइन.
firstly, in discrete time, you have fixed positions, yeah? सारी नहीं हो सकती. So let's say we fix some positions here. You are allowed only these. As a notation in signals and systems, almost all books and all literature will use n for discrete time. Yeah, आपने यहाँ देखा. We had t for continuous time, the x-axis, and for discrete time case we use n. It is convention, it doesn't mean anything. Yeah, but it helps you remember or know that what we are talking about. Also, it's very common to use square brackets for discrete time and curly brackets or curved brackets or parentheses for continuous time. It's just a notational note, doesn't have anything to do with mathematical notation. So this is what happens. Yeah. So now you are allowed only some locations. Okay. Then the unit step looks like this. Before time 0, there is no input, and at time 0 you give it a fixed input. Yeah. So this is like giving a sustained push or a sustained fixed input to the system. Again, this is for vocabulary now. We will come to this later, the impulse response, the step response of a system. Then you will see these inputs in action. Yeah. For now, we just want to know that, okay, when we say step input, what are we going to mean? Yeah. When we say impulse given to a system, what do we mean? Transform. So what is a transform? Alternate form or representation of something. That is the most general way you can put it. आपने भी transforms पढ़े? Laplace transform पढ़ा है. Okay. Circuit 2?
Yes.
What does it do? Laplace transform?
बेसिकली टाइम डोमेन से, सॉरी हाँ, टाइम डोमेन से फ्रीक्वेंसी डोमेन पर आ जाता हूँ, या उल्टा कह रहा हूँ मैं.
Yeah, inverse Laplace will bring it back, but yeah, you're right. It goes from time domain to frequency domain. Yeah, but the two representations, if you draw them, the time domain and frequency domain, are they the same signal or no? Do they represent the same phenomenon or no?
Yeah,
They do, right? So they are alternate forms, yes, or representations of the same thing, and they're not the only ones. There are so many other transforms, right? So in this course, in fact, you will see 3 transforms: Z, Laplace, and Fourier. Yeah. Now, sometimes students complain that this course is bit material is too much, but my argument usually is that usually I do the Z transform first. There are reasons for that. I will tell you later. But the properties of these transforms, the conceptual understanding, and even a lot of problem solving related to the transforms are very similar. So if you understand the first one really well, the second two become very simple. So my argument usually is that actually a big chunk of the course is just repetition of the Z transform. Okay, so we will spend a lot of time on Z transform so that you really get to know the transform, how transforms work, what do they do, what is their purpose. But then if you really understand how to use the transform, how to apply properties of transforms, then Laplace and Fourier are just sort of slight modifications. That's it. Okay. So we will come to that in this course. This is, let's say, a function. Yeah, it's a sine function. What is the information I need to record it? Do I need this whole continuous time hai ye, right? So infinite points. Yes. Do I need to record every value of this function? So what do I need? I need to know that it's a sine function. It has amplitude 1. It has frequency 1 kilohertz. Yeah. If you don't want to record there is a sine function or a cosine function, you could say, okay, it's a sinusoid with phase. In this case, phase is 0. Cosine would mean phase is 90 degrees. But just to simplify, I say, okay, I know it's a sine function. That means phase is 0. It has amplitude 1. It has frequency 1 kilohertz. Frequency का तो idea है, yeah. Okay. So 1 kilohertz is key frequency because it repeats after 1 millisecond. So if you invert that, it's 1 kilohertz. So I only need these 3 bits of information for these infinite points, right? Simple case hai. I just need to store these 3 bits of information to regenerate this guy. मुझे पूरा तो record करने की ज़रूरत नहीं है. Yeah? We will see in Z transform, Laplace and Fourier that effectively that is what they are doing. They are saying, okay, in time domain or in so and so domain, there is so much of this information in the waveform, or the waveform has so many points. But what are the key informations I need to recreate this? Yeah, and why don't I just save those informations and just plot them? वो आपका transform हो जाता है. Z बन जाता है, कभी Laplace बन जाता है, depending on what information what kind of information you want to extract. Yeah. So in this case, is this information. So time domain, but I say, okay, I only need to know that it's a sine function and it has a frequency of 1 kilohertz and an amplitude of 1. Yes. So you see this amplitude of 1, frequency 1 kilohertz. Yes. And the information that it's a sine thing, you will have to record it somehow. Usually we record that in the name. Okay. When I say this is a plot of a Z transform, then you already know which function. I'm not telling you right now, but we know which we are talking. When I say this is the plot of a Laplace transform, then you know already that is it a sine, cosine or a complex sinusoid. We will see that. When I say Laplace or Fourier, wavelet transform, Gabor transform, so many others, we will just do 3 of them. Yeah, but the 3 bits of information are usually collected like this. So now if I give you this and I tell you this is a sine transform, let's call this a sine transform actually, and I say, okay, this figure below is a sine transform and this is the signal that I want you to represent. Can you create that one from here? You can. You know it's a sine transform, so it was originally a sine function. Yes. Secondly, you know I would need to generate a sine function of what frequency? 1000 hertz. Fine. What should be the amplitude? The amplitude information is here. Yes. Later we will see what if this was made up of 2 different sine functions with 2 different amplitudes. Then what will happen? Let's say that it was actually a sum of one sine function with frequency 1 kilohertz and amplitude 1, and another sine function with frequency 2 kilohertz and amplitude 2. क्या ख्याल है? Quick thinkers, यहाँ क्या होगा change? एक और लाइन आनी. So आप उसका वो पूरी डिटेल लेके चंद पॉइंट्स में रिप्रेजेंट कर देते हैं. That's why the transforms are so powerful. Fourier transform, and we'll come to it, is known. ये कहा जाता है, it's well known कि if Fourier transform did not exist, जिस वक्त ये आया था उस वक्त इसका इतना यूज़ नहीं हुआ, अभी पिछले 50-60 साल में इतना हमने इसको यूज़ किया. If Fourier transform did not exist, our development of the digital world would have been delayed by centuries. शायद कोई और मैथ हम ढूंढ लेते, लेकिन undoubtedly for technology, modern technology, Fourier transform is the biggest enabler. Okay, and we will see that. और आपको ऑलरेडी उसकी पावर नज़र आ रही है. A lot of signals, इतनी shapes होंगी, क्या कुछ होगा, देख के लेगा यार ये तो इसको क्या मॉडल करें, क्या लिखें. Fourier transform नहीं है, 4 लाइनें निकली. That's it. Yeah. So you are able to work with those 4 lines. Your computer can just operate on those 4 lines. उसको point by point पूरा signal compare करने की कोई ज़रूरत नहीं रहती. It can compare are those 4 lines in here? Yes, this is the same thing. Yeah? Or इतना mismatch है इसकी. So we will come to that. So it enables compression, it enables detection, it enables classification. मतलब आपका ये neural networks वगैरह भी सारा कुछ इसकी बहुत help लेता है. Yeah. So neural networks का idea है थोड़ा बहुत. Features का बताएं. Feature extraction, right? So this is feature extraction in its very basic form. You just extracted some features. Yes. क्या features extract किए हैं? तो उसकी overall form क्या है? Sinusoidal है. Amplitude क्या है? 1f. Frequency क्या है? 1 kilohertz है. You extracted the 3 key features and you put them in your data. And then you work with the features. यही neural networks करते हैं. They have their own way. Sometimes they use one of the known transforms. Sometimes they extract features slightly differently. Deep neural networks में क्या कर रहे हैं वो आजकल. I'm just telling you these things because these are the things that everybody needs now. Deep neural networks, they don't even know what the features they want to extract. The neural network itself chooses based on practice that I first tried these features and I couldn't classify properly. Training session होता है ना, so training part. Then I tried these features and then I was doing better. वो खुद choose कर लेता है. तो कई दफ़ा उन features की physical, इसकी तो physical interpretation भी सी ना, it's amplitude, it's the frequency. But in deep neural networks etc. Often we don't even know the physical interpretation कि वो उसने क्या features निकाली है, ठीक है? So वो फिर आगे एक और science है. But all of that starts here. शुरू यहीं से होता है सब कुछ. Okay, so let's go back to this thing. Transform की समझ आ गई? Yeah. So I just gave you a primer on the transform, Laplace and Fourier as well. Yeah. Now response. So we said, remember that a system is what? That processes a signal. Yes? An entity that processes a signal. So response is that description of that process. करता क्या है उसको? ठीक है? So response is what system does to a signal entering it. Yeah? So the signal goes in as X, it comes out as Y. Yeah? Now again, this is a black box. This could be a nuclear system. It could be a physiological system, body है कोई, right? This could be DNAs. आपको कोई chemical जा रहा है, कोई nucleotide जा रहा है, DNA कैसे respond करता है उसके, yeah? So this box doesn't care, and that is the power of signals and systems, and later that is extended to neural networks. Yeah, it doesn't care कि वो क्या है. If you could of course write all the physics of your system, पूरी लिख लें आप अच्छी तरह डिटेल में और सारी मेजर भी कर लें हर प्रॉपर्टी, then you can do better than this. But often that is next to impossible unless it's just a simple pulley system है जो आपको फिजिक्स में कई दफ़ा पढ़ाते हैं. उसकी आप फिजिक्स लिख लें पूरी, ठीक है, और आप इनपुट बताएं, आउटपुट पता चलेगा. But most real systems are too complicated to go in and measure every minor detail and then write the physics, chemistry or biology of that whole system. Yeah, from differential equations to then solve कर देंगे, तो आप समझ नहीं आएगी solve कैसे करनी और measure कैसे करनी. So this black box approach that works very well, and it is agnostic to the application, doesn't care. Yeah, again I've been saying this system could be the stock market. Okay, X is the stocks or the money you throw into it. Y is the money you take from it after 1 year. Yeah, so still the principles we learn in this course, they still hold. Okay, so let's start with this thing. Response is what a system does to a signal, entering it. So पता नहीं आपने डबल शार्क का सुना?
Yes.
सुना? अच्छा. So very अच्छा एंटरप्रेन्योर था एक इंसान था. Right? किसको नहीं पता? अच्छा, आप बड़े मासूम हैं, बाकी सारे राइट. सो दिस वाज अ गाय, स्कैम था ये. मैं पता नहीं कब का है इसका. मैं वाज इन पाकिस्तान बट आई वाज रीडिंग द न्यूज़ सो आई नो. अच्छा. सो व्हाट ही वाज डूइंग वाज ही वाज टेलिंग पीपल कि आप मुझे इतने पैसे दें तो इतने अरसे में आप डबल ले लें. डबल शाह उसका नाम पड़ गया था. आई डोंट नो देयर वर मल्टीपल स्कैमर्स, वो मशहूर एक ही हुआ था. कितना देता है?
2 महीने दे देते.
अब वही ना, वो फर्स्ट ही क्रिएटेड अ रेपुटेशन, सबको यकीन हो गया, फिर काफ़ी सारों ने दे दिया, फिर वो गायब हो गया. यार कुछ कोशिश की थी. तो बट just to give you an idea of what we mean by response here. So he says, okay, give me 1 rupee and I'll give you two. So this box is double shah now. He's our system now. Even he can be a system, right? So what is the response then? The response is, if you give me x, I give you 2x. So the response is doubling. Yes, yeah, response. So if we wanted to write it in some very basic notation, later we will see a more advanced notation for responses. Okay, that will cover more general systems. But let's start with the easy thing. There is, if you give me x, I give you hx. Where h for me double shah के लिए क्या है? Twice. Yeah? अगर ये डबल शाह जो है वो हाफ शाह होता कि h 1/2 होता,
माइनस में होता है.
हाफ में भी तो आपके कट रहे हैं ना पैसे, राइट? सो कोई भी ना देता उसको. सो दैट वुड बी अ डिफरेंट रिस्पॉन्स. Next, we will connect it to the previous one. So response is what? It is what the system does to a signal. Yeah. Convolution. Do you know this word? Convoluted. क्या होता है English?
Sir, we basically convoluted, fuzzy. I mean, like वो detail में ना हो या
थोड़ा सा वो
का नाम that name है भूल
एक
गया.
खास डेप्थ तक
डेप्थ हो उसमें और क्या हो, कुछ इंट्रिकेट कॉम्प्लेक्सिटी हो उसके अंदर, राइट? देन द प्रॉब्लम इज कॉन्वोल्यूटेड. तो आपको लगे कि ये हाँ ऐसे करके आ जाएगा, लेकिन पता चले और भी रस्सियाँ तारे स्ट्रिंग्स मौजूद है अंदर. सो अ कॉन्वोल्यूटेड थिंग इज समथिंग इंट्रिकेट, कॉम्प्लेक्स, नॉटेड. ठीक है, उसमें इट्स नॉट इजी टू सिरा कहाँ से पकड़ना और कहाँ से निकालना. प्रॉब्लम भी हो सकती है, theoretical problem whatever. So what do we have to do with this guy? Convolution. Yeah. So yes, as you say, intricate, folded, twisted or coiled, complex है. It's usually used synonymously with complex. मुश्किल, इतना easy नहीं, ठीक है ये मामला. So that is convoluted. But for us, convolution, and you'll see convolution a lot in this course. Okay, so this is now adding to your list or your toolbox of mathematical operators. अभी तक आपने बहुत से सीखे हुए हैं, right? Some of the earliest ones you learn are plus, minus, multiply, divide. Yeah? फिर differential, limit, पता नहीं क्या क्या करते हैं आप. Here now you will add one more, unless you have already added. किया तो नहीं अभी तक.
सर्किट 2 में की थी
सर्किट में एक बार उसने इंट्रोड्यूस किया, मैं कोर्स का पार्ट नहीं था.
थोड़ा सा यानी चलिए सुन लिया था आपने उसका. Yeah, don't worry, I will do it again because it's very integral to this course. I just want you to know if you have heard of it. So it's good you have heard of it. So it's just an operator and we represent it with a static, yeah, convolution. And we will see that in a while. So let me give you an idea. Let's develop that. Quadruple shah, let's say this. इसका कोई cousin आ गया है, अगला level ले. Quadruple तो पता है ना, 4 गुना. Yeah. So he says he has a more nuanced approach. He says, give me 1 rupee today and I'll give you 2 rupees tomorrow and 2 rupees day after tomorrow. Yeah? तब जाकर हमने बहुत simple रखा था, give me now and every day. Yeah? So this guy says, okay, 1 rupee today and I'll give you 2 rupees tomorrow and 2 rupees day after tomorrow. Fine. So let's say you give him a rupee on Monday. Yeah? So what do you get? You get on Tuesday.
Double. And another double on Wednesday.
Yes. Yeah. So firstly, notice what's the difference between this and this one here. This one, it had only one output. To one input, just one output. Double करके दे रहा था, right? और हमने time का उसमें डाला नहीं, ठीक है वो डाल दो. But here, one input leads to two outputs. Delayed. Yes. एक अगले दिन है और एक उससे अगले. Later we will actually write these. That if this is xn, this is xn plus 1, that is xn plus 2. Right? वो फिर we will come to that later. But अभी चले Monday, Tuesday देख लेते हैं. So he says, give me 1 rupee today, and so if you give me 1 rupee on Monday, you get 2 rupees on Tuesday and 2 on Wednesday. Total आपको already पता है 4 रुपये आपको मिलने हैं एक के बजाय. So it's like double shy is like this response. उसका अगर मैं देखूँ तो it's like if I give something any amount on Monday, it goes through that response. It is doubled once. और आउटपुट आता है, then it goes through the second phase when it is doubled again और फिर आउटपुट आता है उसका, right? Now let's make this a bit interesting. Let's say you give him 1 rupee on Monday and 2 rupees on Tuesday. Now quick thinkers, what do you get on Tuesday?
क्या?
Tuesday को कितने पैसे मिलेंगे?
Only Tuesday.
3
Every Tuesday.
sorry 3 नहीं 6
Quick thinkers, quick.
6
Chill. What?
How many? You give him 1 rupee on Monday and 2 rupees on Tuesday. How many? How much do you get back on Tuesday?
6
एक सौ
Five.
से यार, five.
4 sir.
अभी मैं Tuesday.
Convoluted हो गया ना, ये यही दिखाना था ना.
नहीं ये पहले
और देखिए ये कितना आसान था, स्पेशली ये तो बहुत ही आसान था. और जब तक आप एक एक इनपुट दे रहे हैं, एवरीबॉडी कैन जस्ट से लाइक दैट. जो ही मैंने अभी 2 इनपुट दिए, बाद में तो हम यहाँ एक लंबी ट्रेन दिया करेंगे, फिर क्या करेंगे आप? That becomes harder to solve. That is very हाँ अपडेट कर. So क्या बना फाइनल आंसर क्या भाई? जल्दी तो यार, ट्यूसडे को कितने मिलेंगे? कैसे?
सर ये मंडे से पहले वाला दिन है ना, टीज पे 2 दिया
नहीं
अगले ट्यूसडे कितने?
मंडे ट्यूसडे. यस. सो मंडे को आपने उसको 1 रुपया दिया, ट्यूसडे को आपने उसको 2 रुपये दिए, ठीक है?
अच्छा, उसी ट्यूसडे को उसको कितने मिले?
जाहिर है
उसी ट्यूसडे को
कितने मिले?
2
दो
रुपए मिलेंगे
राइट.
तो फ्री
सो वेडनेसडे को कितने मिले?
वेडनेसडे को उसको मिलना है तो 6
2 हाँ 6
कन्वोल्यूटेड हो गया. राइट. सो और थर्सडे को कितने मिलेंगे? 4 मिलेंगे. और फ्राइडे को कुछ नहीं मिलेगा. या सो मंडे के अगेंस्ट his output, if you look at it separately, he is going to give you 2 rupees on Tuesday, 2 on Wednesday. And if you look at this separately, he is going to give you 4 and 4. But separately is not enough. I just asked you how much you will get on Tuesday. I didn't ask you how much we will get on Tuesday for the first input, right? Total आपको चाहिए. So you need to do some sort of a overlapping sum, right? That overlapping sum is convolution. We will write its formula and we will use it. It's just very handy. That's it. इसमें कोई magical नहीं है. बच्चे बहुत घबराते हैं convolution से. There's nothing special in there. Usually you now do it on computers anyway. We will take you through some examples of real convolution on paper. That is just to let you understand the concept behind it. Yeah? Later आपने सारा computer calculator पे करना. But notice now because of these 2 inputs, there is this overlap. आपस में वो आ रहे हैं. और actually in reality there are like a train of inputs and a train of outputs, so वो सारी calculate करना becomes pretty hard. So that helps us do this. So just as an interesting example, this is what's happening. Let's say each box represents one time unit, or yeah. So what you are giving as input is 1 rupee on Monday and 2 rupees on the next day. Yes. The quadruple charge system is 2 and then 2. Yes. So first your input goes in. So he gives you on Tuesday 2 times 1, 2. Yeah. Next day, that is Wednesday, the new input goes in, but the previous input isn't through yet. It is still there. उसका output रहता था. So you overlap 2 times 1 plus 2 times 2. Yes, that is, you are actually doing convolution now. Okay, ये उसका हम बाद में formula भी लिख लेंगे, but now you are doing convolution. On the third day, the response to the first input is over. Complete हो चुका है. Second input का भी second response रहता था. So that will be 2 times 2, 4. And after that, it's completely out of the system, so no more overlap. So you will see when we do convolution mathematically also, that you take the input, you take the system response, you send the first input in overlap, get the output. Then you send more of the input in overlap, get the output. That's it. ठीक है, इसको हम मैथमेटिकली भी लिख लेंगे और ग्राफिकली भी कर लेंगे. But at this moment, what you need to take away from here is what is convolution. Yeah, it is a mathematical operation that helps us calculate response of systems. Okay, that's it. और आपको ऑलरेडी नज़र आ गई सिंपल से एग्जांपल में भी कि things do get convoluted. So we will be back. We will see exact formulas for that. So I will next go to some signal basics. This was the vocabulary. What did we do in vocabulary? क्या क्या किया हमने? Signal, systems, और continuous time, discrete time, response, input वो impulse है, step function, response और convolution, transform या sorry और convolution. अब यही लफ्ज़ बार बार आते रहेंगे, most of them. Okay, they will keep repeating. We may add some more terms, but I cannot make this list too long. So these are the key ones, and I want you to be very intimately familiar with these terms. जब आप उनको सुने सोचें तो आपके ज़हन में एक बड़ी क्लैरिटी के साथ आना चाहिए. This is a set of data or information. This is something that is maneuvering or messing with that or processing that information, right? Response is what actual processing is doing. Convolution is something, a mathematical operation that's going to help me to find that response. Okay? All that. So बड़ी clarity के साथ आपके ज़हन में अगर आएगा, और ये एक ही दफ़ा करना होता है, ये चीज़ें भूलती नहीं अगर आप बहुत clarity के साथ एक दफ़ा लॉक कर लें माइंड में. ठीक, so please do that. And कोई है सवाल इस पे अभी?
Completely off topic question है, मगर जो आपने curious case of quadruple का यूज़ किया, ये by any chance curious case of Benjamin Button मूवी से तो आपने नहीं लिया? वही से लिया.
लेकिन curious cases बहरहाल this term is not new. There are old novels, if I recall correctly, H.P. Lovecraft. किसी ने पढ़ा उसको?
Yes.
I'll try to find उसका है short stories हैं, तो उन्होंने भी पीछे से influence हो गया Benjamin Button वाला, right? Yeah. So yes, off topic and interesting question. Let's go to next one. Again, this we're going very lightly, slowly, so that we have an idea of what we are doing. So in this part we will also complete नहीं करेंगे हम, we'll just go through some of it, we'll see. But now we will do signal basics. Okay, so very basic things about signals. I think there are 1, 2, and 3 sections in this. Okay, so signal basics. What we will do today is types, several classifications of signals, and we will see some examples of that. Yeah, so types means classifications, and we engineers mostly like to classify things. Yes, so we classify कि जी ये mammal है, ये नहीं है, ये scientists in general and engineers in particular like to classify stable है, unstable है, discrete time mechanism, all that. Yeah. So why do we classify? Any idea? And what does that have to do with this
सर
picture?
अपने कन्वीनियंस के लिए करते हैं
क्या convenience है?
ताकि हमें पता हो किस चीज़ को कैसे हैंडल करना है
कैसे हैंडल करना. So when you classify these things, like this is क्या है इनकी क्लासिफिकेशन? ये दो किस्म की प्रॉब्लम्स है.
लकड़ी और लोहा
एक नीचे लकड़ी भी है, क्लासिफिकेशन ख़राब हो गया. दो समय है, दो ऊपर, एक ऊपर है, दो नीचे.
वो ब्लंट है, वो पॉइंटी है.
ओके, दैट्स वन क्लासिफिकेशन. और
इजी टू
सर इसके एप्लीकेशंस एक एक चीज़ के लिए दूसरे दूसरे चीज़ के लिए
right. So another classification is what kind of tool you need. One is a cutting problem, and the other is a hammering problem. ऐसे ही है. Yeah. So as soon as you classify things, you are able to develop separate tools for those classifications, and then a third person comes in and he says, oh, I have a cutting problem, right? So they can use the, उनको फिर हैमरिंग का जो टूल बॉक्स है उसमें जाने की जरूरत नहीं है. Yes, they have to go into the cutting toolbox. Yeah, so they can use the methods, tools developed for that class. So first you classify, you develop tools for each class, and then when whoever comes next, they try to see this is my problem now and it falls in these classes. If it doesn't fall in any of those classes, फिर क्या करना होगा? इन्वेंशन करनी पड़ेगी. फिर उनको एक नई क्लास आ गई है, अब पहले उसका सोल्यूशन निकालें. लेकिन जो अगला आएगा बंदा, अगर उसका their case falls in this 5th class and you have already developed a tool or a solution for this class, they can use it, maybe refine it if they need to, but that's it. So cutting and hammering problem, same is here. So we will classify signals now. We will stick to signals for now. I will classify them. Now the classification will be based on several questions that we will ask, right? And the answer to those questions will define the classes. Yeah? First question we ask is the x-axis continuous or discrete? And this question we have already asked. Yes? Example and continuous discrete. So if your answer to this is that the x-axis is continuous, yeah, then you are talking about the class of continuous signals. If your answer is no, the x-axis is discrete, x-axis, yeah, so then your class of signal or process that you're working with is discrete, yeah, discrete time. The word time emphasizes that we're talking about the x-axis, yeah, but as I've already said, it doesn't have to be time, it can be people, it can be space, okay, so many other things. So first question leads to broad classification. क्या होगी broad classification? Discrete time, continuous time. What was the question? Is the x-axis continuous or discrete? Yeah. So answer to that question leads to these two broad categories. What's the second question? Is the y-axis also discrete or continuous? Okay. So this is what I mentioned last time. If the answer to this question is that yes, the x-axis was discrete or discrete, and the y-axis is also discrete, then you are talking about digital. So now you have this additional classification. And the classification of digital versus analog is actually this, that analog is continuous on both axes, whereas digital is continuous on discrete on both axes. Yeah? If it is only discrete on x-axis, it is only discrete time. It's not digital. Okay. So what's the third question then? Yeah. So we discussed this last time. Most signals in real life are analog, or at least the phenomena that you see. Both x and y are continuous. What do we mean by continuous? You look at a range, every value there is allowed along t, and also along x, every value is allowed. Yeah. So then you are talking about like the temperature in this room. The temperature you measure in general will be discrete. Yeah, small modern devices, most of them are digital, so they actually discretize everything. Yeah, but temperature by its nature is a analog phenomena. Yes, वो अलग बात है कि हम डिजिटाइज करके फिर काम करते हैं, उसकी भी वजह है, वो आपको पढ़ाया होगा डिजिटल लॉजिक में क्यों करते हैं. राइट, एनालॉग लॉजिक इज़ फार बिहाइंड डिजिटल लॉजिक. सारा वहीं से मसला शुरू होता है. तो हमारी जितनी हमने डेवलप की है ये सारा कुछ, दिस इज डिजिटल लॉजिक. So if we want to use digital logic, we have to digitize. Yes. So that's a bit digression. So we often digitize. So what do we mean by that? We make both x and y axis discrete. So we say, okay, we will sample, and then we not just allow every value of temperature. We will discretize those values. Yeah. So if you discretize it in let's say 9 levels, then you have 0, 0, 0, 0, 0, 1, 0, 1, 0, right? You make binary or whatever you want to make, but you want to discretize along the y-axis also. Okay, how we do it is a separate topic. It doesn't matter right now. What we want to see is that it is digital or not. Then the third question. So what was the first question?
So x-axis का दूसरा
X-axis
y-axis
is
Exactly.
continuous.
Second question was,
y-axis.
is the y-axis also continuous or discrete? Third question now is, does the signal have a repeating pattern? And I can tell you this, a lot of mathematics changes, like branching हो जाती है. Function periodic है नहीं है, पूरा tools ही अलग हो जाते हैं. कौन सा वैसे आपके यहाँ से ज़्यादा आसान होता है?
Periodic
Periodic, क्यों? हैं? नहीं, continuous होता है.
predictable behavior.
Predictable
behavior.
behavior है. Behavior repeat होता है.
Repeat,
एक साइकिल में जो उसने करना है अगली में भी वही करना है. So if you understand every aspect of one cycle, that is just gonna keep happening. Yeah, so आप पूरी साइकिल उठा के भाई कहेंगे आप एक साइकिल को स्टडी करें ऐसे. Yeah, so does the signal have a repeating pattern? Yes, it's periodic. No, it's aperiodic. Yeah, so this question, and we know when a signal is periodic, you are used to defining its features. Okay. Yeah, what are the features we can often talk about? The time period, or its inverse, the frequency. Then there is the concept of fundamental frequency and high frequencies. So T naught is the time period, length of the minimum repeating pattern. Why do we say minimum?
आप बड़े उसको भी लेकर कैसे रिपीट हो रहा है.
Right? समझ आ रही? You know, somebody could say that the repeating pattern is from here to here. ये पूरा repeat हो रहा है. They would be right. Yeah, होगा ना. So, but does that represent the actual frequency? No. You want the minimum repeating pattern. इस case में minimum repeating pattern is this part. Yeah. And also the minimum repeating pattern as a whole, this could be look different, could be looking different, right? कोई यहाँ से शुरू, क्योंकि repeating है ना, अब starting point तो हमने तय नहीं किया, किसी ने कहा है कि यहाँ से शुरू करना है. So there's another person could say it's this, that's fine. Now this part is repeating throughout. Yeah. So in a way it's a bit non-unique kind of thing. Yeah. The area will be same, of course, in these two cases, or wherever you start, and if you start here and end here, even then all cases will lead to the same area. But it leads to an important formulation, which is this: a signal is periodic if there is a t naught, for which you can write xt equals xt plus t naught. But the important bit here is this thing: for all t. What does that mean? अगर इस equation को आप पढ़ें, this is what is shown actually in the figure, saying wherever you want to start, t start and xt, and then equals xt plus t naught. So this person started at t equals -1, yeah, and went up to -1 plus 6, yes, whereas this person started at t equals 0 and went up to t naught, the same t naught, that is 0 plus 6, yeah. So it's not enough to show that for some particular t, एक t के लिए आप show कर दें कि वो xt equals t naught, और फिर another t पे it fails. That means that it was only periodic for a while, then it became aperiodic, yeah? एक दो cycles की और फिर aperiodic. But truly periodic signal is which shows this behavior for any selection of starting point. So in this case, yeah, we see that's fine. Then we also have this result. It's very obvious. It's similar to what I've been describing. That the notice, why are the two integrals the same? For a periodic signal, so this holds only after you have established that the signal is periodic. How do you establish that a signal is periodic? If you can prove this thing in the red for all t, then you have proven that the signal is periodic. We will see some examples of proving that in general case, and maybe sometimes in specific cases. But once you have proven, then the area under one whole period of a periodic signal is always the same, no matter where you start. That's what we're saying. Yeah? So the upper one starts with a equals -1. The lower one starts with a different point, b equals 0, as long as they integrate over t naught. दोनों ने full t naught के ऊपर integrate किया, yeah? Continuous t naught. So that is an important result. We will come back to that. ये fourth होना चाहिए. Sorry. So this is fourth question. Third क्या था question?
Is it periodic or
periodic तो definition होगी ना. Does it have a repeating pattern? That was the question. Yeah. So what is this question? Are the signal values or parameters random? Randomness क्या होती है?
not expected, yeah, basically not predictable नहीं है. Opposite
Without
of
some,
opposite.
let's say, discernible order. Yeah. So it's the opposite of deterministic. Yes. So when can a signal be random then? Let's see. Let's look at this signal. It's deterministic. If I say xt is sine 2 pi ft with f equals 1 kilohertz. Yeah. Now this is a deterministic signal. Anyone, anywhere in the world, ये इक्वेशन मैं उनको दे दूँ, f बता दूँ, they plot it, यही आएगा, right? कुछ और चेंज नहीं होगा उसमें. It's a completely deterministic signal. This course stays within deterministic signals. Okay, we don't go into random. For that we have graduate courses, random processes, and sometimes undergrad courses, statistical signal modeling. But you don't have that here. But still it's good to know what is a random signal then. So random क्या होगा फिर? Let's say we say that xt is sine 2 pi ft, but f is chosen by probability आ गई, याद आ गई probability. f is chosen by, let's say, a random phenomenon or random way. यहाँ easy case बताया है कि you choose f by heads or tail. Okay. Now you tell this formula to someone. आप करेंगे, आपका फ्रेंड कहीं और बैठ के करेगा, ये दोनों सेम प्लॉट करेंगे या डिफरेंट? फ्रेंड करता है, अगर उसका हेड आया, आपका टेल आया, उसका भी टेल आया, आपका भी टेल आया, राइट? सो दिस इज ए रैंडम सिग्नल, बट द फनी पार्ट इज दैट द सिग्नल वंस प्लॉटेड डजंट लुक रैंडम। नहीं है ना, कुछ बड़ा बड़ा क्लीन सा साइनसॉइड है दोनों केसेस में, या? सो रैंडमनेस डजंट ऑलवेज हैव टू लुक रैंडम, बाय द वे, ओके? हम जब रैंडमनेस सोचते हैं ड्रॉ करना हो तो हम वो सारा ऐसे ड्रॉ करेंगे, कितना स्मूथ है दोनों, but this is a random signal because one of its parameters is based on a random occurrence, yeah? वो occurrence ये हो सकती है कि अगर 10 लोग आए तो ये करना है, 15 लोग आए तो ये, जो ही नहीं वो टॉस ऑफ कॉइन तो हम वैसे ही आसानी के लिए डाल दें, लेकिन रियलिटी में तो पैरामीटर्स होते हैं कि अगर ऐसे हो जाए तो ये कर रहे हैं। हाँ, आपको पहले से पता नहीं होता उस केस में कि इनमें से होना कौन सा है, चांसेस होते हैं आपके जहन में 50% ये है, वो भी प्रोबेबिलिटी थ्योरी आना शुरू होती है, राइट? सो did any of you take probability with me in the summer?
No.
नहीं लिया? So that's a very fun course to take. आप लोग कर चुके हैं ना?
Yes, sir. Good.
हंस रहे हैं, मज़ा नहीं आया?
तो CS के साथ आया था बस, but
वो तो खैर है, हैं? So I think that is the most conceptual and that is the course that tests your logical abilities more than almost any other course in undergraduate. Probability जो है आपकी logical approach को test करती है. This is my claim. जितना वो test करती है ना, कोई और चीज़ नहीं करता. At least in our curricula. या वो फिर आप वो चीज़ों में जा सकते हैं. So right, fifth one, ये नंबर गलत चल रहा है. Fifth, does the signal have finite energy or finite power? So let's see. Maybe we can stop after this one. I'll just explain it a little bit. Okay. We still have some time, but let's relax a bit. So ये एक important classification है. It helps us work with the signals and systems. So let's look at that. Of course, to answer this, you need to know this thing first. Yeah, energy क्या है, power क्या है of a signal? किसी को idea है what is the power of a signal?
सर पावर एनर्जी पर टाइम
हाँ, सही है, यही निकलेगा इन दी एंड. लेकिन सिग्नल के लिए क्या होगा, राइट? सो फर्स्टली ये वाला, व्हाई आर दे नीडेड? सो मेजर्स आर इम्पॉर्टेंट. वी वर्क विद मेजर्स अ लॉट.
सर वैसे ये सारे तो वो नहीं खिलाएंगे ना ब्रांचेज, जैसे उसमें तो आप कह सकते हैं ना, जो पीछे आप क्लासिफिकेशंस कर रहे थे कि जो कोई भी सिग्नल है ना वो इन क्लासिफिकेशन में फॉल करेगा. या कोई ऐसा सिग्नल नहीं हो सकता जिसमें ना आपकी कांस्टेंट पावर हो ना कांस्टेंट एनर्जी हो. तो
बिल्कुल हो सकता है. वी नॉट सेइंग दे विल ऑल फॉल. इवन जो पीछे भी हमने बताई है ना, नॉट ऑल सिग्नल्स हैव टू फॉल
In that class.
right? So what we are saying is the most common classes that we come across, right? So here, why do we measure things? Let's say you go for an interview and the interviewer asks you how was your performance in undergrad, yeah? And you say, yeah, in the first semester I did average, then I had flu and did bad, then I was really working hard. तो उतनी देर में वो अगले पेज चला
ये
जाएगा.
डाउनफॉल बड़ा खराब नहीं है इसका
बहुत
कोर्स
bad screen है.
0.0
बड़ा आप लोगों को बड़ा गम लगा. आप अच्छी बात है, आपको फीलिंग आई है कि ऐसे नहीं होना चाहिए. डोंट वरी, ये मैंने रैंडमली पिक किया है, राइट? व्हाट आई वांट टू ब्रिंग होम इज द कांसेप्ट ऑफ मेजर्स. या सो इफ यू स्टार्ट टेलिंग दिस टू द इंटरव्यूअर, दे विल गेट बोर्ड, राइट? क्या कहते हैं, मेरा CGPA 3.4 है, दैट्स इज व्हाट हैपेंड देयर. यू समराइज्ड अपनी पूरी परफॉर्मेंस को एक मेजर में ले आए, राइट? ये CGPA था, क्या उसमें भी खराबियाँ होती हैं, मसाइल होते हैं, लेकिन बहरहाल ह्यूमंस लाइक टू स्टार्ट विद दैट. इफ दे आर मोर इंटरेस्टेड देन दे कैन आस्क यू कि अच्छा फिजिक्स में क्या दिया था, उसमें देन दे कैन गो. बट यूजुअली वी वांट टू फर्स्ट गेट अ फील, बॉल पार्क फिगर. या सो CGPA is a measure of this signal, है या नहीं? ये सिग्नल ही है ना?
Yes.
यस, यहाँ पे हार्ट बीट रुक जाती है सिग्नल नीचे जाके. सो ये वाकई 0.09 लिखा हुआ है।
0.7.
हाँ वही 0.09
आया ही नहीं एक क्लास लेके चला
I don't know.
ये मैं क्वेश्चन
है? सही है। अच्छा, so that was one measure that you already used, and you use many other measures by the way. But in this course, two measures that we are interested in are energy and power. So we define energy as the area under the absolute square of the signal. Okay, area under the absolute. Again, measures are never unique. Okay, कोई होता है किसी को इंटरेस्ट हो, what was your maximum GPA that you got? What was the highest GPA that you got, for instance? Yeah? Or somebody might ask, how many times did you get a GPA above 3.5? Honors list में कितनी दफ़ा आया? Yeah. So measures are never unique. Okay, they are conventions. They help us talk to each other, summarize some processes, some information. Yeah. So don't think that this is the last word. कि energy है तो बस क्यों आया बस यही करना. बहुत और भी बहुत सारी हैं. Signal की what's your measures? But here I'm just going to talk about a couple of them that show up in this course. So it's the area under the absolute square of the signal. So for example, if this is your signal, firstly, is it continuous time or discrete time? Continuous time. Is it analog or digital? Analog. Is it periodic or
Periodic.
periodic? Right? Okay. So the energy is basically क्या कह रहे हैं? Absolute square of the signal. तो absolute square आप करेंगे तो वो नेगेटिव वाले भी
Positive.
पॉजिटिव होके स्क्वायर होते जाएगा सारा. ये शेप आएगी. It's just a general shape. We're not really going into the actual values. And then you take the total area, or you try to take the total area under that. Now there is a question. समझ आ रहा है सवाल?
सर एक पीछे क्या जरा सर अगर एब्सोल्यूट ले ही रहे हो तो स्क्वायर करने की क्या जरूरत है या एक्चुअल में नहीं करते हो एब्सोल्यूट स्क्वायर ही कर लेते हो
क्या ख्याल है आपका? क्या मतलब?
सर क्योंकि अगर हम सिर्फ वो ले लेंगे तो वो तो एरिया कैंसिल आउट हो जाएगा सारा.
नहीं स्क्वायर से वैसे ही
वो तो आप अगले सवाल के जवाब से ही बता रहे हैं. इनका सवाल ये है कि स्क्वायर ले ही रहे हैं तो एब्सोल्यूट लेने की क्या जरूरत
नहीं उस पर तो मैं इसके साथ एग्री करता हूँ. क्यों
है? हाँ, तीन मान के.
स्क्वायर नहीं
We can vote on it and then just decide. Decide the truth by democracy. Right? So क्या वजह है अभी? Absolute. अब टेस्ट होगा आपका मैथ. कितने कोर्स पढ़ चुके हैं मैथ? तो पढ़ चुके हैं. तीसरा साल में 4-5
मेरा सवाल ये भी कि स्क्वायर क्यों ले रहे हैं आई मीन एब्सोल्यूट क्यों ले रहे हैं इसको स्क्वायर ले ही रहे हैं कुछ स्क्वायर माइनस स्क्वायर से क्या करता है तो क्यों एब्सोल्यूट में लगा रहा है.
So I haven't talked about that, but I think mathematically you should have an idea. Signals, complex numbers, right? भाई complex number का square और उसका absolute square same होता है या different होता है?
कैसे सवाल मुझे
Complex numbers पढ़े आप?
हाँ पढ़े.
Let's say z is a complex number.
ठीक.
Then the square of z and the absolute square of z, are they the same thing or not?
देख रहा हूँ मैं लिख कर देख लेता हूँ.
रियल नंबर्स में सेम होते हैं, कॉम्प्लेक्स नंबर में सेम नहीं होते. मॉड्यूलस का स्क्वायर बन जाता है, राइट? तो इधर मसला ये है, आप वो रियल नंबर्स में सोच रहे हैं और यस एब्सोल्यूट विल कन्वर्ट फ्रॉम रियल नंबर, द नेगेटिव विल बिकम पॉजिटिव, बट सो डज द स्क्वायर डू. बट इन कॉम्प्लेक्स नंबर्स दैट इज नॉट द केस. करके देख लें, जी को लिखें a प्लस बी आयोटा और उसका स्क्वायर करें और उसका एब्सोल्यूट स्क्वायर करें. एब्सोल्यूट मींस इसके केस में z टाइम्स z कॉन्जुगेट, यस वो z एब्सोल्यूट स्क्वायर होगा. तो आपको वैसे ही नजर आ जाएगा. एक है z टाइम्स z, दूसरा है z टाइम्स z. कॉन्जुगेट सेम नहीं हो सकते. सो दिस इज टू allow generalization into complex valued signals, and we in real life, in actual problems, we work with complex valued signals a lot. Okay, So I will stop here. But that's a good question, and here also I wanted to tell you कि अपनी आदत बनाए कि जब आप कोई नई चीज़ सुने तो आपके जहन में सवाल उठना चाहिए. Yeah? Don't take things as they are. If you read this formula, you say, okay, why the square, why the absolute square, why both of them, वो जो आपने पूछा, very good. लेकिन most students they don't ask why not just xt. So some of you already answered. वो measure तो useless हो जाएगी ऐसे cases में, right? Because the positive areas will cancel the negative areas. Yeah. So that is it. We will come to this classification next time, inshallah.
एक और सवाल पैदा होता है,
जी जी कुछ
हम स्क्वायर ही क्यों इस्तेमाल करते हैं अगर एब्सोल्यूट ही लगा रहे हैं?
क्या
अगर हम एब्सोल्यूट लगा ही रहे हैं तो फिर स्क्वायर क्यों लगाते हैं?
Yeah, again, as I said, वो तो complex में तो फर्क है, that you understand, right? But then you want another power other than square. Yes? So yes, those measures exist. nth वाले भी होती हैं. As I said, they're not unique.
सिर्फ एब्सोल्यूट लगा के हम लोग क्यों नहीं जनरलाइज कर सकते? क्योंकि वो तो उस पर भी चलेगा, कॉम्प्लेक्स नंबर्स पे भी हो
लेकिन ना let's say अगर हम कॉम्प्लेक्स पे ना काम कर रहे हो ना,
जाएगा.